Um, this is a gasoline generator I dismantle for the project of a fuel generator. So, like today, experiment I want to conduct. You can see the motor here. The motor here is it can run on 12 volt and 24-volt motor. So, which I have a 12-volt battery here. Each is a 7 amp. Uh, this is my generator. This one is a modified stator. See, it is a modified stator. I have already rewind it. So here is the unmodified stator. So you can see here is a capacitor line. Here is the main output. Then this is a battery charger. It has a inbuilt battery charger. So this is my armature. I can call it Lotto. So this is my 50-watt bulb, LED bulb. So now I want to first of all couple it with a modified stator. You can see I have my capacitor here is a 15 UF and 24 UF capacitor. So I have these two capacitor. We experiment it with these two capacitor. So now I have to couple the generator. First of all, we couple it with this modified stator. Modified starter. We couple the generator with modified starter. So with this Lotto, you can call it Lotto, you can call it emission, anyone. So far you understand the. So now let me first of all put the starter. So let me put the emission inside. Okay, this is the cover. Let me have to put this dot so that it can align. Okay, just enter. So now let me okay. So now we couple the other one. Make sure you tighten it firm. So that the armature will align. So you can see it's rotating freely. There's no any clacking or cogging on the Lotto. Rotating freely. So now I'm going to couple this generator on the frame I make. So let me put it inside. So first of all, so I'll sit it firm. and now sit firm. So now I'm going to, so it is very easy to dismantle and mantle. So now first of all I have to uh, tight here. Then first of all come over here, come over here. Then make it this tight is very well. Okay. So when you shake it now, I'll rock it. Okay. So now um I have to run the system. So let me name my my meter. So so this is my meter. Yeah. But first of all I have to read the value of this I have to read the value of this capacitor. I have to read the value. So let me do that so that okay. Let me see. So now you can see the meter. So let me put it over here. See it. So now this is the capacitor. So now let me press the terminal for the capacitor. So you can see the value of this capacitor. Okay. So now let me check this 24 UF to read the value. Okay. See it. So it's good to check. Sometimes there's some fraction down. There's some fraction down. Okay, now so I have to run it first of all. To I will connect this 15 UF capacitor to the terminal of the generator. So let me change it to read AC. Yeah, maximum is 700. 700 is maximum. So I have to do the connection to read AC. Okay. So now let me connect the terminal of capacitor to the 15 UF capacitor. Okay. Now this is the battery. This is the battery. 12 volts. So I have to arrange it to 24 volts to run the system. Okay. So from positive to negative. So the actual end will give me uh, 24 volts. Okay. So now let me put it. So let me run it first of all from 12 volts. Okay. Oh, sorry. Okay. So you can see it. There is no actual. It is 15 volts output. I'm connecting. I run the motor on 12 volts. So now let me run it on 24 volts. So 395 with 15 UF. Okay. So now let me connect 24 UF. So now running it. Let me test it again. Running it from 12 volts, 19, 20 volts. Then let me run it on 24 volts, 410. You can see 410. I'm running it with a modified stator. So now I will run it with unmodified stator, which has a self-charging. self-charging. So I will run it with modified stator. I mean unmodified, factory rewind stator, unmodified. So I will run it to know the how many voltage it will give me on 12 volt and 24 volt. So now I will dismantle this generator. I will dismantle it again. Okay. So first of all, I have to lose here. Okay. Then lose here. Then pull it off. Let me remove this meter terminal. So now I will dismantle the generator and put it unmodified stator. I will put it on modified stator. So now let me. This is a kind of experiment. So you have to experiment to to know the one that give you the desired result. So let me apply. So the armature shock will pull out. Okay. So this I'm removing this modified stator because it gives me high voltage around 400 and something volts with just 24 UF capacitor. Okay. So now I'm gonna put this unmodified stator. You can see it has a 6 wire. This one is for capacitor. This is for battery. This is for 220 for us as appliances. Okay. So now let me couple it back. Okay. Make sure that it fit very well. So okay. Let me put the armature back. So let me put the center load. So now let me rock it so that it won't pull out. Again, let me set this dot. Okay. Yeah. So it have to align with this. Yeah. Perfect. So now let me tight it again. So I have typed it. So you have to make sure that the armature is rotating freely. You can see it is rotating freely. So there's no uh, uh, physical interaction with stator. The armature and the stator doesn't have any physical interaction. So it is rotating free. There's no any cogging anywhere. So now I have to couple it back on this frame. I have to couple it back again. So I have to couple the generator back. Okay. So now let me connect the generator. You can see it is very easy to couple. Oh, yes. Let me raise it. Raise it once again. Okay. So I have uh, I have tied the shaft. So now let me also apply it on the generator so that it won't be vibrating. Yeah, so that it will be sit perfect. See, so tight it very well. So make sure that it is aligned to avoid vibration. Yeah, it's aligned. It's aligned very well. Okay. So now I'm gonna connect the put my connection, put the my meter to measure the volts. So you can see my meter. So I'm going to connect it on the on 220 terminal. So I have to put the capacitor. I'm connecting first of all connecting a 15 UF capacitor. I'm first of all connecting 15 UF capacitor. So now I will run it from 12 volts, run it on 24 volts with 15 UF capacitor to know the amount of voltage it gives me with the different value of capacitor. With testing with a 12 volt, run it on 12 volt and 24 volts. So now let me run it on 12 volts. Okay, 6 volts output. Then let me shift to 24 volts. Okay, 192 volts with 15 UF capacitor. Okay, so now let me change the capacitor value and connect this 24 UF. connect 24 UF capacitor to the generator. So now I will run it from 12 volts and 24 volt. Remember on 12 volt with 15 UF, it gave us 6 volts under 12 volts. Then on 24 volt, it gave us 190, 191 volts with 15 UF on 24 volts. So you see the difference now. So I'm going to run it on 12 volt first, 24 volt second, then with 24 UF microfarad capacitor. So I'm going to run it to see the difference. Okay, first of all. Okay, on 12 volts, then give us 8 volts, giving us 8 volts. Then let me shift it to 24 volts. On 24 volts, 222. Wow, that's perfect. So with this unmodified core, there's no need of modifying it again. It gives us a perfect voltage. There's no need of stressing yourself modifying it, because any modification with this speed, it will go higher. It will go higher voltage. Maybe we're getting something like about 250 or thereabouts, which will be dangerous to home appliances. So with unmodified, let me check the resistance ohms first of all. Okay, 10. So 10 ohms resistance. So let me run it again. 8 volts. Very, very perfect. So very, very massive. So with 15 UF 190 something volt, with 24 UF 220, and it runs very, very smooth. Runs perfect. Okay. So you can see the experiment today is that with good speed, uh, uh, no need of modifying this stator. Now, okay, I forgot. I have to remember. I will run this motor on 12 volts and 24 volts. Then I have to test it with this self-charging battery to see that with 12 volts, the voltage this battery charger that we bring can be sufficient to recharge this battery. For those asking uh, to use the internal charger just for this set to charge the battery. Okay, now I will run it with 12 volts and 24 volts to see that even with 24 volts, the voltage you'll be getting here can be sufficient to charge this battery, because for you to charge this 12 volt battery, you need at least 13 to 14 volt to recharge 12 volt battery, and for you to charge 24 volt battery, at least you need at least 28 to 30 volt to recharge it. But we have to test it with 12 volt to see the uh, output of this output voltage of this battery charger. Okay, so now I have to change my meter. I have to change my meter terminal connection to the battery charger. So now let me remove it. Let me remove it. Okay, so now the voltage is very, very stable. I can connect my bulb, connect my light without damaging it, because the voltage is stable, and it won't harm it. So let me let me connect it. At the same time, I can read the output voltage of the battery charger. Okay, so now I'm gonna run the system with 12 volts and 24 volts. 12 volt and 24 volt at the same time. Okay, so remember I connect it from the main output of the generator goes directly to this bulb, while the battery charger I connect it to the meter so that I will measure it from 12 volt and 24 volt. How much voltage the battery charger can give me. This is the capacitor terminal. Okay, so now let me run the test. I mean on 12 volts, there's no signal here, but voltage generator is low. So even there is no signal from the battery charger. I'm running it on 12 volts. Okay, now let me run it on 24 volts. Okay, there is right here output. You see? Let me remove it again. So now let me connect on 12 volts. There's no signal. There's no signal. On 12 volts, there's no signal. But there's no signal from here. There's no signal because the generator is induction. It has to run some revolution. It has to run some minutes before it can build some power. Then it can feed it back before it can generate output. Okay. On 12 volt, there's no signal. Then on 24 volt, you can see. So even on 24 volt, the the output of this generator is giving output charger from this generator is giving 12 volt. So which means uh, if you're using this thing to charge this battery, it can't charge it. Remember, it is on 24 volts, but it's generating giving 12 volt, and this 12 volt cannot even charge 12 volt because to charge 12 volt, you need a higher output voltage. So you can see it's running perfect. The speed, everything. Running perfect. So you can see the difference here is that with this battery charger, can charge unless you can modify this charger too, but I haven't done that. So, but from factory winding, you can't even recharge 12 volt, surface of 24 volt. You can see, I connect the motor is running from 24 volts, running on 24 volts. So you can see the connection running on 24 volts, but the output from this generator uh, ambient charging winding, giving 11 12 volt, 11 12 volt. So which is not even suitable. It can't even it will be showing signal, but it can't charge the battery. The battery will be going down because for you to charge 12 volt, you have to use at least 13 to 14 volt to charge it. So the bulb is writing fine. So thank you for watching. If you like the video, you can share. If you have a feedback as well, the system is running. Despite that I put the damper, but there's no vibration, but the alignment is almost perfect.